morning, good afternoon, evening, everyone. My name is Eric Bush. I'm the CEO and co-founder of Demand Driven Technologies and delighted to be your host and presenter for today's webinar on Autopilot. We call this a small step, but a big leap, and hopefully you'll find some very interesting capabilities during the discussion today. A couple notes before we get started. First of all, the session is being recorded so that we can distribute a link to the recording for all attendees and registrants. That'll be made available to you after the session later today or tomorrow. We'll also be sharing with you a copy of the presentation I'll be using to kind of guide the discussion along the way. As we've done forever, in our webinars, we are keeping all attendees on mute. So please use the webinar control panel to ask questions. We will cover off any questions that come along at the end of the session before we wrap up. And we really appreciate your interest. And as well, we're going to be doing some polling during the session today because we are gathering information about the perspective of clients and prospects and other attendees to these events to help us guide our path forward. So we're going to ask a series of 2 sets of questions along the way, and your prompt attention to providing your responses to those polling questions will be greatly appreciated. So with that, let's get started. From an agenda standpoint, I always like to start with kind of an understanding on market realities because I think it should guide our efforts as a solution provider, and it's important to have that context understood because it very much has a lot to do with what we're trying to do with this autopilot feature we'll be talking about today. We're going to talk about some of the basic limitations of safety stock settings and some of the things that we've learned through all the research we've been doing on this topic over the past couple years that really helped set the table for the autopilot feature that we'll then talk about. I'm going to talk a little bit about the process we've gone through in development. This has been over a 2-year journey. I don't think we are anywhere near the end of the road in the context that we are working in, but certainly have learned an awful lot during this process. We were able to get our design kind of patented. And so we're proud of that, but also we know that the work will not be done for any time in the near future. There's more and more that we can do, and I'll share some insights about where we're heading with some of these other features as we get through the end of the demonstration, and we'll talk about next steps and kind of closing comments. So with that, many of you have seen me present this chart. This is kind of the reason why DD Tech exists. This is based on data from the U.S. Federal Reserve. It shows the inventory to sales ratios of manufacturers in the U.S. over that past 25-year horizon. And while there were some improvements kind of in the heady economic boom times before we had the big economic recession, the Great Recession as it was called, we're basically turning inventory today at the same rate we were 25 years ago. And that is a startling realization or point of awareness. If you look at it today, there's about $1 trillion of inventory in U.S. manufacturers, and just think if we could squeeze 5 to 10% of that out, if we could free up 10%, that would be a release of about $100 billion in working capital. So there's a reason to go after this because it's obviously not been improving. Companies have spent an immense amount of money in the past 25 years on software, ERP systems, you name it, to try to get to a better place. But for the most part, we're standing still or we're treading water, however you want to look at it. And the other reality we see in our discussions with clients is that the software that's out there is rather complex. I liken it to the users being kind of in the same role that the Apollo astronauts. That's a view of the Apollo capsule. The astronauts at the time, this is back in the 70s, were the best of the best of the best. They had the right stuff, as we called it. They were part of the computer because computers weren't that powerful at the time. Batteries certainly weren't what they are today. And to get to the moon and back, they had to flip a lot of switches, turn buttons or turn knobs and push buttons and the like to get to the moon and back safely. And so when we have the solutions that are in the marketplace today, whether it's your ERP system or a supply chain planning platform, the reality is that it's a daunting challenge to get up to speed with how to work with that solution to get proper results. And it's very heavily user dependent. And so, you don't really get much in the way of confirmation. If you're trying to set safety stock settings, you don't get any kind of visual view that says, oh yeah, you got that one right or you got it wrong. So there's always this level of anxiety that users talk about in getting the systems right. And quite honestly, if they're not confident, what do? Most users will pull out an Excel workbook, start generating some of their own logic and try to come up with an answer that at least they can defend because they know the logic it's working with. And, a great example of this kind of challenge and the level of skill required is, that age-old quest for finding valid safety stock settings. So with that, we're going to kick off a little poll here. We're going to ask you 3 questions. And so, Kevin, if you can go ahead and trigger that, that would be great. First question is, how often does your organization update safety stock settings? And you've got some choices there you can pick from. And let's be kind of candid about this. We're not going to score or turn anybody in if they don't do it that often, but we'd like to kind of get an understanding of how frequently and how rigorous the discipline is in our clients for those elements. Second question is, do your users trust the effectiveness of the safety stock settings? So it's one thing to set the settings up. It's another thing to have confidence that you've got them right. So in that case, it's kind of a yes or no answer that we'd like to have come back. And then finally, the third question is, do you have the ability to test the effectiveness of your safety stock settings? That kind of goes hand in hand with the trust and confidence in the settings. But in many cases, we've seen that clients really don't have any technical way of simulating or testing whether the safety stock settings that they're generating are actually going to be viable or work for them in the manner intended. So, Kevin, over to you when you're ready to share the results. Eager to see what we get here.
All right, we'll give folks another 20 or so seconds, and then I will publish the results.
Yeah, appreciate any of your responses here. We really value the input that we get from this, and it really does help us kind of with our focus on our engineering and software development features and the like.
All right, looks like we've had a few more trickle in. I'll give it another 10 seconds, and then I'll end and publish. Okay.
Okay, so let's look at this. This is the answer on question 1. How often does your organization update them? About 39% are saying they're not doing it, or it's only done semi-annually. And the balance are saying quarterly or monthly. One person indicating that they're doing it weekly, which is great. But it's a task that can be a bit of a challenge. And then can you scroll down a little, Kevin, there so we can see the next 2 responses?
You have to do that manually, Eric.
Oh, I can do it on my screen?
Yes, you should be able to.
Oh, sorry, I didn't realize. My apologies. So, do we trust our settings? 39% say yes, 61% say no. Do you have the ability to test the effectiveness of your safety stock settings? 3 folks indicated they can, and the balance said no. So we're at 87% saying they're not able to test those settings. So appreciate your feedback on that. Very, very interesting. All right, so let's talk about what's involved in all that. And here we go. This is kind of, you can go Google up safety stock methods or settings. You'll get all sorts of different formulas. Many of us, like myself included, are not that adept at understanding the notation formula that are being shown on the screen here. But a lot of them are really driven off statistical formulas: standard deviation, the demand coefficient of variation, what's called a z-score. Some of them include lead time elements, others don't. Some of them include average order size and the like. But there really are some flaws with that because they're all assuming a normal distribution in terms of demand pattern variation and the like. Often they're not easily understood by users. People will resort to their own methods and the like, but suffice to say, there are challenges in this arena, and it's not as kind of reliable in terms of a method as we'd like it to be. We even implemented in Intuiflow a set of capabilities around statistical red zone calculation methods. And this would use the traditional Z factor, a probability factor, and it would generate red zones based on that logic. We did this as a client was interested in exploring this, and we thought that might provide a little more concrete empirical value for setting up your red zone or safety zones in your buffering settings. What we found was that it was rather problematic. Especially if you're shooting for high probability factors like 99 or 100%, it became very, very sensitive to the volatility in the demand signal and the standard deviation calculations related to all of that. And so while there was initially a fair bit of interest in it, very few clients have continued to apply that kind of an approach. And then as well, the DDMRP method, describes how to utilize different lead time ranges to set a base red zone factor, and then to complement it with a set of variation ranges. And as the variation ranges go up higher, you would put additional safety coverage in to protect for that. And one of the questions that we would always get in implementations is why are we doing it this way? Well, the grouping idea was really to help ease and simplify the administrative of these elements in the setup of your item buffers. And that makes sense. And a lot of clients have gotten really good results with these kind of techniques. But we also saw that there were some distortions that we were getting. Some items in a given range would have either too much or too little compensation. And so it's could be a little bit of a challenge to really get it dialed in. The other thing we saw was that items with the exact same COV value, in this case, you can see 3 different items here with a coefficient of variation of 130%, meaning that the standard deviation of demand was 130% of the average rate of demand. And that is yielding 3 different red zone sizes. So wait a minute, they all have the exact same statistical score. Why are they getting different red zone factors? Part of it was the pattern, the actual shape of the demand, which may score out to the same COV value, coefficient of variation value, but in reality have their own personality to them. They have their own behavioral kind of attributes relative to how their demand actually comes in. And so what we were seeing is that items with the same COV would need different amounts of red zone coverage. And we also started identifying that there was an implication here as well for other elements of the item master data, like its lead time, like its minimum order quantity and the like. So you can see here, the planning line is the purple line. That's when a reorder was generated, and you can see the supply arriving some days later. And in this case, it's a longer interval than it is here. And in the item above, it's much, much shorter. You can also see the weight of the green zones varies here. In this case, the green zone is maybe 3-4 times the rate of usage over the lead time. In this case, it's at some factor higher than that. And then in the one above, it's nearly, the amount of usage over a lead time. So we knew it was the convergence of all these factors that was really going to be important to understand to help us get better settings for the user. Because the idea in my mind is if we could take one of those switches or one of those configurations out of your Apollo space capsule, your supply chain software, then we're starting to make the workload easier for users, giving them more confidence that the settings that they're utilizing are going to be valid and helping us go forward. This is another view of that same story. You can see this is the dispersion of the required red zone size. This is a factor of 5 times the rate of usage over the lead time. And you can see here, it even relatively low levels of variation, COVs less than 2 and the like, you've got a pretty wide dispersion here. You'll also notice that these are peaked at 5. And what we found in our research was that if we left this unconstrained, some of these would be up in the 7, 8, 9, 10 times the rate of usage over the lead time. And once you get up to that kind of threshold, what you find is that you are carrying an awful lot of inventory for a demand that may or may not ever really appear. And so that kind of was a grounding state that says maybe there's an upper boundary here, because from a financial management concept, yeah, there's some items that probably don't make sense to hold stock in, and therefore you wouldn't need a safety stock value or a red zone factor value to work with. There is a general correlation to be sure, but there's still a very, very wide range of coefficients of variation or red zone sizes that relate to a given level of variation. So with that, we were kind of inspired. I'm a musician. I like to play music. I love the music app Shazam on my phone. If I don't know the artist, I can't recall it for whatever, I'm getting old. I'll click the button on the Shazam app on my phone. It will listen to an audio waveform in the air. No matter what part of the song is singing, it will digitize it and then match it to a library and come back with the answer in a matter of seconds. It's really cool and amazing technology. And even in a crowded restaurant with a lot of noise, you can barely almost hear the song in the background. Somehow this app can filter that out and find the song and the artist by doing this process of taking an analog waveform, matching it to a digital library, and giving you the result along the way. And we thought, boy, if that's possible, maybe we can really understand the uniquenesses of these demand patterns and utilize that as a way to get a better result than our statistical formulas were providing for us. And that's really what inspired us. Now, so with this in our mind, over the last couple of years, we started marching down this path, trying to figure it out. And what we learned was we had a lot to learn. But we had a core set of concepts that were kind of guiding the effort from that standpoint. First of all, take a holistic approach. Make sure that we're looking at the whole picture. It's not just that variation pattern. There's other elements at work here that we have to understand and incorporate, even down to the level of what your planning calendars are and other factors like that. Let's see if we can use AI/ML technology to help us generate better results. And let's do this with one primary goal in mind. More than anything, I want us to find a way to get users more confident that the system is working the way it should. Why is it that, we can have civilians going into outer space with SpaceX, with limited training, cool looking spacesuits and iPads, and yet we can't make simple safety stock settings more reliable and confident for the user, right? If we can do that, then obviously we can gain the benefit of getting the system to do more of the work. Let the user's role be not to check the math of the system, but actually to get involved in things that need human intervention, like product transition, a supplier disruption, other factors like that. Why should planners feel like they are there to check the math of their computer? That seems like a real big waste of time and energy on things that we should be able to do better with. And so kind of based on the inspiration of Shazam, based on what we see SpaceX doing with space exploration and the like, we went to work. We engaged a customer advisory board. We wanted their feedback. Again, the whole principle here is let's make sure we come up with something that users will be confident in. And let's get their involvement, because the more we have their voice in all of this, it'll serve as a grounding board to make sure that we don't just get all, tuned into our technology and lose sight of the end game that we're really after here. These customers that we've worked with, including Coca-Cola Beverages of Africa, Greif and Aptiv, have played a massive role with data, feedback, testing in live production environments that's really helped the effort substantially. We also went in it with this idea that, hey, there's three phases that we want to think about. One is, how do we get the initial buffer set up? And we're going to primarily rely on demand histories. This is part of how we engage with new clients. We do simulations and other factors like that. The more we can assist with getting credible and valuable results out of that setup phase, the more we get the wheels turning here. Then, as we go forward, and now we have part histories where we've implemented, we are utilizing the solution, there will be further insights we can gain from that can further enhance the value that Autopilot can create. So obviously using part histories, doing a further evaluation of how can we further adjust the Autopilot functionality is kind of the lens that we're getting into now. And then going forward, how can we make further ability to adapt? How can we build a system that allows users to be pacing to the actual demand in the market, because that's the most clean signal that we're ever going to get, and at the same time be ready for whatever comes their way without being heavily reliant on forecasts. Part forecast can help us understand the scenarios going forward and really help us provide some validation. In fact, we'll talk about this. We've actually pulled some of this into the current version of the autopilot feature, a concept called forecast validation, that after it generates the red zone factors and the like, will then validate them against the forward-looking forecast to further ensure that if it has a seasonality or certain unique patterns of its demand that we need to understand whether we've got the right answer. And we'll show you that in the software here shortly. So going back, we started with this idea of clustering. We were trying to stay aligned with the DDMRP concept of buffer profiles and ranges of items clustered together. We found that that was problematic. It was not giving us consistent results. And it was also resulting in some of that over and under compensation. So we kind of broke the paradigm a little bit and shifted to focusing on item level settings. Not that the user should be responsible for doing that, but that if we want to really get better results, we got to understand the unique characteristics of each item, and that would be the best way to go. We had a prototype that we shared at our conference last year. We had a first release of the software that was out earlier this year, and we shared at our user conference this year. We were learning a lot, getting better results, but also knew that a lot more work had to be done. And here's just a quick, I'm not going to go over all these items, but there was a lot. Every time we turned a corner, there were more things to learn. Things that we thought would work a certain way didn't. We had to pivot, figure out other ways to deal with it. But some of the things that are on this list are really important because we've not only identified them, we've addressed them. One of the most critical pieces of the story is data exceptions. A user will not be confident if we are simulating data that is flawed because they're saying the system doesn't understand. It's coming up with recommendations that make no sense to me because there's outliers in the demand, or there's some other distortions in the part specific arena that need to be factored in. So data exceptions is a critical part of the story, and we'll show you that real quickly as well. The need for calendar alignment. It's got to match your calendar. So your operating calendars, whatever calendar assumptions, because they have such a critical role in the planning process. That can include planning calendars where you may be on milk runs and other factors like that. We have to align to whatever system settings you've got set up. What are your ADU horizons and other factors like that? Our initial concept was that we would have two min-max values or two min-max types, a high and low setting. And we saw that we could actually simplify that and come in with one min-max approach. Item variation had to be evaluated from historical demand because when we tested against forecasts, they tended to be too smoothed out and didn't provide that variability and volatility that is so pertinent to being able to get good safety stock settings. So a number of these factors have been identified, worked through, and further improved in the release that we now have available. So we've enabled the data exceptions. We've adopted an S&OP simulation logic to leverage our calendars, items, and system settings. This really helps with the forecast validation. It's also kind of the core engine that does the validation that the settings that we're getting are going to work correctly. We've made a lot of enhancements to the logic and algorithms. And we developed an autopilot workbench that has save, use, override functionalities, very, very flexible and easy to work with kind of a platform. And then obviously there's been a lot of testing and evaluation with the customer advisory board clients that we've been working with. So with that, let's jump over into the software here and get this. All right, there we go. Here we go. Okay. We'll one more place here quickly. So let's start with data exceptions. No, my Zoom is in my way. Go away, please. We'll come back here. Here we go. So the data exceptions idea is the following. We know that there can be all sorts of distortions in master data. Everybody in supply chain has had to live with this. And we also knew that if we generated a recommendation, an autopilot recommended buffer setting on data that was flawed, that the users would lose confidence because they'd much rather hold those off to the side. And this was an important part of the discussion with the clients we were working with. So you can see at the top of the page, and this is the standard feature within the solution, that it identifies the different types of exceptions that we would want a user to pay attention to. If there's outliers in the demand, If there's like no raw material costs, no lead time, we can't really generate proper results for you from that. If there was not enough demand to meet the minimum thresholds, meaning it would be essentially a non-buffered part, you wouldn't hold stock in that. If your MOQ exceeded your order interval days, if it was greater than your total demand, those aren't going to hold you up from running an autopilot recommendation, but they're like calls to action to say, does this really make sense to be buying this much material if it's going to be more than a year's worth of demand? Should we go back to the vendor if it's a bought-in item? Should we look at changing our batch sizes? Because implicitly, if our MOQ is greater than our total demand, then obviously in that year's horizon, we're carrying more than a year's worth of supply, and our inventory turns are going to be pretty much non-existent. So those exceptions are utilized to kind of filter down, and there's critical exceptions and non-critical. The critical ones will keep and prevent us from generating autopilot recommendations. The other ones will be flagged and identified, but you can still get a recommendation from it. The next aspect is here in the site admin in our settings area under processing, where we look at the autopilot configuration. And you can see here some enhancements from the previous version. One of the points of feedback we got from clients is that, hey, for certain service levels, we may want to choose what is the autopilot method that we're going to adopt, meaning would it be min-max or a dynamic buffer, as an example. And you can arrange the service level thresholds by how many demand pulses in a year, in this case, we experience. If there's more than 30 pulses, I'm going to let the autopilot come up with a recommendation, because it may be that a min-max setting would be as valuable or more valuable than a dynamic buffer. Or I may say I want to bias towards dynamic DDMRP buffers. You have the ability now to do that. You can set thresholds at your discretion, what these service levels will be, and the system is going to go about the process of doing the pattern recognition, looking at the item attributes, generating simulations to validate that the recommendation it's coming up with are valid, and kind of tuning those to meet the service level targets that we have at the lowest levels of inventory. So now you have the ability to set these. This can preordain that in certain categories, like if I've got slow movers in a maintenance, repair, and overhaul business or spare part business, and I've got that long tail to deal with, I might want to dictate that those are going to be min-max settings, just because a dynamic buffer, when you have very infrequent demand, will kind of move up and down and be inconsistent to what you're looking for. You also have the ability now to do this forecast validation. After it gets the settings, looking at the historical views, it will run them against the forecasted rate of demand for those items and allow you to validate that the choice that it's making is the right one. So we'll go through an example of this here shortly as we go through some of the other autopilot features. We have an upper red zone factor limit, and you can set this as high as you want. In this case, it's 5 times the rate of usage over the lead time, as you can see in the tooltip. The yellow zone is usage over the lead time. And so this allows you to kind of set your upper boundary in terms of how big that will go. If I set this low, then I may have items that can never achieve their service level target because we don't have enough safety coverage. If I set it too high, I may be carrying way more stock than I need to, and I may be able to curtail that back. So this is a configuration option you've got. As well, we added a feature where we can add safety coverage. So because the logic is achieve the service level at the lowest inventory possible, there may be points in that parts simulation that actually are flying pretty close to the ground. Some users would say that's a little too close for comfort. Why don't we add another 5% of usage over the lead time, or 10% as we've done here, so that we've got a way to ensure that we don't bottom out. And that's a great idea, because now I can start with a higher setting here. As we gain confidence in the setting and the overall autopilot results, we can start to dial this back and further squeeze inventory out of the system. You look back and you generate a simulation. And so you want to know how many weeks back do we want to look at this and how many weeks forward do we want. We're using a 52-week year here in both of these scenarios. And then also there's exception for new and expired parts. If I have a part that had no demand history and then all of a sudden started having demand history in the last couple of months, hey, maybe that's a new part. Maybe we're going to need to handle that one, especially if we generate a recommendation on that, it will probably look a bit odd, and we don't want to do that. And the same applies to an expired part that may have had demand in the beginning of the year, but has apparently gone out of usage, and we don't see any further demand on that. Maybe that one should automatically be excluded, because it should probably be non-buffered. Even if there's some inventory left over, we're not going to be able to get it cleared out because that part has gone out of service. So these settings are kind of there to be utilized and adjusted. We're trying to keep it minimal, but also relevant, so that we're getting after the right elements along the way. And so with that, we can go into take our first look at the autopilot feature. So let's go into autopilot. And this is the base console that we get to. You've got the ability to create all sorts of different save views here. So I'm going to go to the line item 1 view here. This is a group of items that run on a production line in our environment. And we'll just kind of give you an orientation of what you're seeing here. This is showing you the 11 items that run on this production line. It's showing you their current inventory level and what the autopilot recommended average inventory level would be based on its analysis, and what the improvement opportunity would be here. There's a pretty sizable reduction opportunity. You can see we're hitting the targeted service level of 100% for these items. They have high rates of usage. 7 of the 11 are going on a dynamic buffer, and 4 of them are going on a min-max buffer. And we can see the corresponding improvements for each of those core cohorts. When you look at the display down below, you can see the item number, location, other details, whether it's ready to implement into autopilot, what is the recommended method, whether or not it's past S&OP validation or forecast validation, shows you what the forward-looking service level was, showed you what the min-max service level was, and what the buffered inventory values were, and service or min-max values. So you can see kind of the correlation of these. It also compares to what the current inventory is, as well as the target inventory, right? So these are all based on, right now, if we look at this item, it's going to be on a specific buffer profile in a more conventional make part with relatively short lead time, moderate variability, and using an order cycle to size its green zone. But that value there allows us to kind of get an understanding of what the current target inventory is, and what our current inventory is, and what the autopilot selected inventory. So I think the interesting thing here about this view is you can see in this case, the autopilot is recommending a lower target inventory. In this case, it's actually higher, lower, higher, lower, higher, lower. They kind of go back and forth that way. And what this gets at is that issue of doing things in ranges tends to either over or under compensate. And so we're getting better fidelity with these recommended autopilot settings that are coming out. You can see the inventory change. So it kind of gives you the breakdown of this 1.8 million of savings as to which items are going to be contributing to that. And in this case, we're actually looking to carry a bit more inventory. If we go to, we're going to just pick one of these random items here and take a look at its situation, and we'll go into part properties and into the autopilot simulations. We're targeting 100% service level. Both the min-max and the buffered method are preferred. You can see the demand history here, and you'll see that there's, recurring demand. It's getting demand pretty much every day of the week, but it's rather lumpy. There's some pretty high periods, and then there's some other periods that are rather low. And what it's generating is, hey, here's what, if we use the buffer technique, what our performance of the buffer would have been. This tracks back to these inventory values that correlate to the two options, the min-max and the buffer. Here's what the min-max views are. You can see we're not getting anywhere close to bottoming out because we've got that yellow zone or that additional red zone safety factor working for us and propping those up. Down below here, you can see a comparison of what the current settings would be. So this is on a conventional DDMRP buffer, and what the actual performance has been. And this is really valuable because this allows us to say, okay, here, based on the current settings, if I let the system do the work, here's what its achievement rate would have been. It would have made 100% service, it would have had good inventory levels and the like. And to the right would be the view of the actual buffer trend graph, which is showing the user, here's how you've actually planned this item. And the idea here is to get correlated to how is this actually been planned, build confidence that, hey, if I took my hands off the wheel and let the buffer do its job, I might have had better results. And then comparing that to what the autopilot recommendation would be, so I can see that, hey, actually, I'm going to get a little better coverage with the autopilot, it's going to give me real good settings and we'll get good value from that going forward. You can actually see a comparison too of, in the current for settings that you're using, what the inventory value would be, as well as what the actual performance has been over that same time horizon. So the idea here is to be very graphical, very visual. We don't want to be in a black box mode. And obviously, as a client and their staff start getting comfortable with this, we want them to utilize these visuals as a way of gaining confidence in the way the item is behaving. Another aspect that we have then is the ability to use part sim. So here we're looking at historical simulations. We're going to use the autopilot setting here, and we're going to test it and run it. It's going to go and generate the result. This is very close to that 50-odd thousand of average inventory value we saw on the previous page. There's a little nuance here because of the starting point is the actual on hand, whereas on the reverse simulations we're doing, we have some base settings that we utilize to do that because we can't really have the perfect picture of where the starting point was. And then we can see the min-max view on this one as well and run that to validate that. We can also then turn this off and look at the forward-looking view. And so here we're going to see that actually the min-max method is going to result in a higher level of coverage. Perhaps the demand pattern in the going forward period is lower than it has been historically. Those min-max values that we generated on a historical view may be overcompensating. And we can then also evaluate the go forward view based on what the autopilot recommendation is. The inventory goes from 58,000 down to 30,000 and it achieves a very high service level. We've got a little bit of a blip out here, so we probably want to keep our eye on that, but otherwise very, very, very good performance from this as we go out in time. So the idea here is through autopilot, be visual, make it not a black box, make it not mysterious, show them the demand pattern, give them confidence that the settings that we're generating are making sense, give them the ability to compare that to how they've actually been performing and what their current settings might have been, and give them the ability to be able to move forward with those values. At the end of the day, what we'd want to do is turn these from ready into enabled. Then autopilot would run and generate the results and set those settings. You can then monitor them, so you don't have to go all in right at the beginning. You can do this kind of part segment by part segment to gain confidence in the system. Give yourself a little more ability to be, looking before you leap, but all in the spirit of gaining that user confidence in what the system is recommending and generating. One final view I wanted to share with you here is kind of an expanded view of line one, and this is another view that you can create. And this summarizes for buffered A and buffered inventory. It shows you the service level and the inventory level for min-max A, min-max A in service level and inventory. Same with the service level B category and min-max B category. It gives you kind of a composite view of everything that we were showing there in that pop-up screen. And so it gives you a lot of clarity that you can utilize to get confidence that we're getting the settings dialed in. We've got visuals on it. We've got an understanding of what our inventory improvements can be. And at the end of the day, the more we can help you get to where settings are being generated for you instead of with untrusted and inconsistent result producing statistical methods, that's a big gain forward. And if we can then get you to help get more items on auto approval so that you don't have to be checking and validating the math of the system, we're reducing your workload and getting you in a position where you can focus your time and energy on the things that really, really matter. So quite a bit there. I don't want to fire hose you too much, but I hope you can see that we've really tried to be focused on bringing to life this idea of a visual, easy to understand platform that's also taking one of those kind of difficult issues. As you know, many of you were only doing updates quarterly or even semi-annually. Confidence level was there. And the reality is, 87% or whatever it was said, we don't have a way to test whether they're actually going to work for us. And we're providing that for you here with the Autopilot platform. So with that, I'm going to go back to the presentation here quickly. And we've got a few more polling questions. So Kevin? So Two questions that we're asking: do you believe Intuiflow's autopilot feature will provide improved safety stock settings? Yes or no? Very easy to make that choice. Do you believe the visual elements of autopilot will enable greater users' confidence? Are we getting away from that feared black box setting? So we'll give this a couple minutes and get your results, and then we'll share those with you. How we doing, Kevin?
We're doing good. We still have a few trickling in. Give it another 20 or so seconds. All right, looks like that's everyone. So I will go ahead and end the poll and share the results.
Wow, I feel very good. 95% confidence in getting to better safety stock settings through autopilot's feature. So I really, really appreciate that. Very, very delighted to see that. You believe the visual elements of autopilot will enable greater user confidence? 95% again. So really great to see those kind of results. And you know, the proof is in the pudding. We're beginning to roll out the feature with a lot more clients going forward. I think some of the recent settings that we've added around the forecast validation, the ability to control if certain items in certain demand pulse ranges want to be on certain methods, we can preordain that, and that will be quite valuable for users going forward. So we're pleased with that vote of confidence. Thank you so much for that. But the work is not done. So I wanted to share a couple things with you here that kind of would be indicative. This is some further analysis that we've done. We've not actioned this yet in terms of the software development, but one of the questions that comes up in implementations, especially on the DDMR3 front, what should be my daily usage horizon, my ADU horizon? And some people have their own theories. It should be 4 weeks of trailing and 5 weeks of forward, or whatever the idea is. And you know, as you saw, there were certain items that tended to do better on min-max settings, which are kind of a static buffer settings. And what you see here is the following. This says to achieve the targeted service level, what is the amount of inventory required based on different ADU horizon days? So in other words, the further right we go, the longer that ADU horizon is. The further up we go, the more inventory we're carrying. So what you can see here in the general view, and these are for 100% service, 99, 98, etc. As we go out, we get better results. So the tendency is that longer horizons work better than shorter horizons. And the reason for this is that we tend to see that if we're using trailing rates of demand, we'll tend to be overcompensating when there were peak periods, or undercompensating when there's heavy periods of demand, and overcompensating when there's lighter periods of demand. And that the more stability we bring into the buffer, in general, the trend is very positive in that way. So this is kind of a normal, this kind of looks like some of those parts that we were showing you in the webinar or in the demo. This one has some more volatility in it. And again, that same paradigm shows that as we get further out to the right, we see lower inventory levels to achieve the targeted service level. So again, kind of reinforcing that longer horizons tend to be better. And then we also discovered that there's something you absolutely don't want to do. We can be more prescriptive about this. And this is looking at an item that has kind of a 180-day cycle of demand. So it's got a peak period, then a trough, then another peak period, and those are 180 days apart. And in this case, the last thing you want to do is have your horizon be right in the middle of that range. So if this is a 180-day range, don't use an ADU horizon of 90 days because you're always going to be out of phase. By the time you reach this peak demand, you'll be looking back at a period of very low demand and you will be undersized. And then when you get to this slack period of demand, you're going to be reacting to peak demands and you're going to be dramatically oversized. So this is just one example of some of the further research that we're doing. I think it's got some pretty interesting potential. It's one of those other settings that you have to think about. And the more science that we can bring into this, the more we can believe we can help you kind of get that level of confidence going forward. So just wanted to share that as kind of a preview of some other things we might be doing. We're gaining user confidence. We've gotten feedback. Your feedback today is very, very much in the same kind of direction of what we're getting from clients. We believe that the technology we've developed, which is patented, is resolving to a much better way the inherent limitations of statistical methods. So that's great, but there's more and more work to be done. We're trying to use visual cues as a way to gain user confidence. I think your comments indicate that that's consistent with what other clients have told us. So we're going to continue to push on that. There may be things that we can do to make those visuals even more easy to reconcile and gain confidence in. Clearly, if you phase in your use of autopilot, you're going to have the chance to build user confidence, and that's the end game that we're all after. This new version of autopilot is kind of a second generation of the tool, and it's available in version 2024.7 of Intuiflow, and there's some further enhancements that'll be coming probably in every release going forward because we continue to find areas that we can make improvements to. So we would love to help you if you're not an existing client, or even if you are, we can utilize autopilot now to generate simulations of a client's prospective results. And there's a link on our website, or reach out to us directly. We would love to help you do that. I am on a mission to help move that needle. Go back to that first slide that showed lack of inventory turnover improvements over the last 25 years. That's why DD Tech exists. It's here to help clients get to a better place. And we're dead committed to making that happen. And, kind of one more shout out here for SpaceX, who landed the super heavy booster in the chopstick tower. I mean, whatever you want to call this is just amazing technology. And if you can think about it this way, that if people can engineer that kind of capability to send up a rocket with 33 engines in it and land it in some wild contraption like this tower with the chopsticks, as they call it, then obviously there's a lot more we can do to make material planning and inventory planning and supply chain easier for users. And so trust that we are going to continue to push in this direction and never rest until we get to a much, much better place for all of you and our clients. So with that, we're going to end the webinar. Thanks again. We'll send out the recording and the presentation materials. We wish you all the best on your demand-driven journey. Have a great day.
Eric, we do have a few questions.
Oh, yeah, my goodness. Got all caught up in my little SpaceX diatribe. Questions?
Yeah, so the first one is off the back of your closing comments, and it is, when will version 2024.7 be made available?
It's available now, and so we're ready to go.
Excellent. Another one from Eddie. Hi, Eric. Do you need the SNOP module to utilize the forecast validation feature?
Yes. That's a requirement. I mean, we think that's a very, very core piece of the platform because it helps clients get a better understanding. Some clients aren't doing much forecasting. We've got a demand planning module that could help them with that. But there's that extra turn of the crank. Often the companies that aren't forecasting really don't see that much dynamics in their demand patterns. So maybe they don't need it as much as others that are probably in a growth phase or seeing changeover in their portfolio, but it comes with the requirement that you have the SNOP functionality.
All right, and the last question I have at the moment is, how would or can autopilot help detect or improve buffer settings for highly seasonal items like those in the agriculture or fresh produce market?
Yeah, it's absolutely going to learn and understand from those seasonal patterns and generate red zone factors or safety stock or min-max settings based on that. So, and then obviously if you've got the SNOP validation, it's going to further confirm that the results we're giving you are built for that. So I think that's one of the strengths of this. It's going to do a much, much better job for you. There may be situations where if you've got those kind of patterns, using a forward-looking rate of demand to size your buffers would be more effective. And you can model that with the part simulation capability I showed you there with that one part we went through as well. So I think it's a much more holistic way of dealing with that. and certainly would outrun any of the statistical techniques people might try to use to deal with that scenario otherwise.
All right, and we did have one more come in. Had any of your major clients adopted Autopilot for all inventoried resources in their system?
I think we are right on the cusp of that. Most have still been kind of in a pilot mode. We wanted to get to this new version, the second gen, as I call it, because it brought that forward forecasted validation coming in. But yes, we've got a number of clients that have, I can't know right off the top of my head if they're all items are on, but the vast majority of their buffered items are certainly utilizing it for sure. Yep.
All right, and that's all we have so far. Thank you, everyone, for those questions.
Thanks again, too, for your responses to the polling questions. We'll share those results with you as well. Again, we wish you all the best. Have a great day, and we'll talk soon. Thanks, everyone.